everyone, we're going to be looking at rearranging formulae today. So this is another one that was quite a common one for the revision topic survey. So a quick starter, I want you to just have a go at these. So pause the video now, see if you can solve the following equations. So you should end up with a value of x, so a number value for x to solve these. So pause the video now, have a go at this. Okay, assuming you've done that, so we've got for the first one, x is 5 over 2, x is 10, and x is 7. You could actually have plus or minus 7 for this last one, so well done if you managed to get plus or minus 7. Either answer is correct, but if you've just got 7, that is fine. It basically comes down to the fact that you end up with a square root of 49, which could be plus or minus 7. So if you've just got 7, that's great. If you've got plus or minus 7, that is even better. Okay, so solving equations, which is what we're just doing there in that starter. Basically what we're trying to do is undo all of the steps that were done to the algebra term until all we're left with is the algebra term. So on this one we've got a square root of 2x minus 5 equals 3. So you can see the thing that was done last to it was the square root, because that's on the outside. So to undo that, we can square it, so do the opposite. So we square it to undo that, and we end up with 2x minus 5, and we need to square both sides, so that equals 9, because that's 3 squared. So now, we can see if we imagine we had a function machine to get 2x minus 5, we would have put x in, we'd times it by 2, and then minus 5. So the next thing we need to do is undo the most recent thing, which is the minusing 5. So to undo minus 5, we need to add 5. So we add 5 to both sides, and we end up with 2x equals 14. So now we can see again, if we think as a function machine, if we had x and we end up with 2x, we've times it by 2. So the opposite of that would be dividing by 2. So we end up with x equals 7 for that one. So basically each step of the way you're thinking, what's the next thing I need to do? And then what is the opposite of that process? So you need to think, if it was the most recent thing was minus 5, you need to add 5 to do the opposite, until we end up with just x equals a number. So let's have a go at this one. I'll work through this one as an example, but if you want to pause the video now and have a go at yourself, that is great. Okay, so again, if we imagine a function machine to get this, so we'd be going through, so you've got x going in. First thing we do is times 2 to get 2x, then we'd be adding 5, so we've got 2x plus 5, and the next thing we'll be doing is timesing that whole thing by 2. And that gives us 2x plus 5. So if we put x through this function machine, we end up with this. So it can be really useful to draw a function machine because it helps you work out what order you need to undo it in. So let's start. So we've got 2x plus 5 equals 3. So again, back through the function machine, we get to the times 2, but we want to do the opposite. So we're going to divide both sides by 2. So we are going to end up with a fraction on the right, but that is fine. So we divide the left by 2, that just gets rid of this bracket, so we end up with 2x plus 5. And that equals 3 over 2, so 3 divided by 2. So then the next thing to do as we go through the function machine was adding 5, but we're doing the opposite, we're going to be subtracting 5, because we're going backwards through it now, so we end up with 2x. And so we need to take it from this side as well, so we end up with minus 7 over 2. Okay, so we've got 2x equals minus 7 over 2. So the last step was timesing by 2. So again, we're going to do the opposite and divide by 2. So we've got x equals, so we divide that by 2. We had minus 7 over 2. We've now got minus 7 over 4. So we can see if we go back, if we think of it as a function machine, it really helps us with the order. So I think with this one, quite a common problem is kind of knowing what to do on each step, but maybe not the order. So a function machine can be really useful for this. If you draw that first, it makes it really clear what order you need to do the process. If you kind of can work it out just by looking at it, that is great. You don't need to do the function machine, but it can be really helpful if you are struggling with the order. Okay, so we've had a look at solving equations, but what we're looking at today is rearranging formulae. So the key difference between an equation and a formula is an equation will have a numerical answer, whereas a formulae formula, will have not a numerical answer. It'll be something in terms of something else. So let's have a look at this formula here. So we can see that the difference is, rather than just having one algebraic term like x, like in the ones we were just looking at, this has got f and it also has c. So what this is a formula that links the temperature in Fahrenheit, which is f, to the temperature in Celsius. And we can use formulae to convert between things like Fahrenheit and Celsius. So what we can do using this is, if we know a temperature in Celsius, we can substitute that in, work out all the maths on this side, and that'll just pop out an answer in Fahrenheit. But if we were trying to do this the other way, and we had a temperature in Fahrenheit and we wanted to work it out in Celsius, this formula we couldn't just substitute in Fahrenheit and it wouldn't just give us an answer in the same way. So that is why what we're doing today is really useful. We're going to look at rearranging formulae so that we can get it, so that we can just substitute a number in and it just gives us the answer. And this is really useful in maths. This is probably, I think, one of the most useful things you'll do in maths all the way up to GCSE. So really, really important topic. Okay, so let's do some examples of rearranging formulae. So this is really similar to the process of solving equations, in that what we're doing is we're trying to get the answer x equals and then something. It'll just happen that in this case it won't just be x equals a number, it'll be x equals something else. So let's have a look at this first one. So we've got y equals x minus 2. And we want to just end up with x equals something, or something equals x. So basically we're trying to get x on its own. So what could we do to both sides of this equation to get just x? So we can see that the x is on the right. So we've got x minus 2 there. So we need to kind of undo the minusing 2. So the opposite of that is plus 2. But because it's an equals, we need to do that to both sides. So we end up with y plus 2 equals x. So we've got x on its own now. So that means that x is now the subject of the formula. We've got it on its own. So our answer to this one would be x equals y plus 2. So all I've done there is switch the sides of the equation. So either is fine. You can leave it in this form if you prefer. So you can leave it like that or like that. I think usually this one is the done thing now. If you're making x the subject, you generally have x on the left hand side, but either answer is valid. Okay, let's have a look at a slightly trickier one then. So we've got y equals 3x plus 2. So this one's a bit trickier because we've got a couple more steps. So we are still trying to get x on its own. So let's start by removing the 2 from both sides. So we end up with y minus 2 equals 3x. So we've got the x on its own, but there is also a 3 there, so we're going to need to get rid of that. So we've got 3 times x, so we need to divide by 3 in order to just get the x. So we end up with y minus 2, we're dividing that whole side by 3, so y minus 2 all over 3 equals x. So we can see we've got x on its own, that is now the subject, so I'm just going to write it out with the x on the left. So we've got x equals, it was y minus 2 all over 3. So just be careful when you're dividing, you've got to divide the whole side. So whereas y minus 2, we divided the whole of the y minus 2 by 3. Okay, let's have a look at this one. We've got a square root in this one, so it's going to be a little bit different, but the idea is still the same of what we're doing. So we've got y equals root x plus 1. So the first thing to try and do is get x to be the only term on the side. So we're going to take away 1 from each side. So we're going to end up with y minus 1 equals root x. And so what do we need to do to a square root of something in order to get back to the original thing? So what do we need to do to square root x to just get x? So what we need to do, we need to do the opposite of square rooting, which is squaring. So I'll represent that as a little 2. So we're doing that to both sides. So we end up with y minus 1 squared equals x. So notice on this side, I've not written y squared minus 1 squared. I've not just squared each term, and that is really important. That is probably one of the most common mistakes with this kind of one. You can't just square each term, because that is not the same as squaring the whole side, which is what we're trying to do. So our final answer would be x equals y minus 1 squared. So we've got it in its final form, x equals y minus 1 squared. We can just leave it like this. You don't need to expand out the right hand side unless it specifically asks you to. If it tells you what form to give your answer in, you might have to do more steps. But this is completely fine. X is the subject because it's on a side on its own. Okay, let's do the last example on this one and then we'll do a bit of practice. So y equals x squared minus a all over 4. Okay, so this is the first one we've seen where we've got a fraction on the side of the x. So what we really want to do is, if you've got a fraction in a formula, you kind of want to get rid of the fractions where you can, because they do make it a bit trickier. So what can we do to get rid of the fact that we have it's all over 4 as a fraction? So fractions, it's the same as, if we've got over 4, it's the same as dividing by 4. So what is the opposite of dividing by 4? We're going to times both sides by 4. So we end up with 4y equals, now on this side we were dividing by this 4, but when we times by 4, that just gets rid of the denominator. So we just end up with 4y equals x squared minus a. And you can see what we've done there, we've got rid of the denominator. So now we can start doing a bit more. So we've got minus a, we're going to get rid of that next. So we're going to add a to both sides. And even though it's an algebraic term, still fine to do it, you can just treat it like a number. So we've got 4y plus a equals x squared. Okay, and last step, what do we do to x squared to get back to x? We need to square root. So on the right hand side, because we're square rooting the whole thing, we also need to square root the whole of the left hand side. So 4y plus a, that equals x. So we've got our answer. Again, I'll just write it with the x on the left. So x equals square root of 4y plus a. You can see we've got x on its own again. So when we're rearranging the formula, all we're doing is getting it so that something that wasn't originally a subject is now on a side on its own. So with the Fahrenheit one, before on the previous slide, it would be equivalent to getting it. So it was, instead of having the Fahrenheit one on its own, it would be Celsius equals and then some other function. Okay, so there's a few here. If you want to have a go at these as a practice, you can do. The main task is going to be on Dr. Frost, so if you're feeling quite confident with it, you don't need to pause the video and have a go at these. But what I would probably recommend doing is having a go at a couple of the hard ones if you are feeling confident with it, just to check you have got it before you move on. And here is the answers for those ones, so just check that you've got those right before you move on. If you've got any of them not right, go back and just check, see if you can see where your mistake was. Okay, so we're going to look at one last type of formula that flummoxes quite a lot of people. So basically with these ones, we've seen this top sort, which is where we've got just x and the coefficient of x, so the number in front of x, is a positive number. And these are a bit easier to solve because you're basically just a bit more used to them with positive numbers. So with this, you'd add 3 to both sides. So you end up with y plus 3 equals 2x. And then when we've got 2x, we can just divide by 2 to get y plus 3 over 2 equals x. So what do we do when we've got a negative coefficient of x? So the number in front of x, rather than being 2x, is now minus 2x. So there's kind of two ways we can do this. We can either do it more similar to what we've done up here, or rearrange it to make it a little bit different first. So what we can do is, if we add 2x to both sides, so this is method 1, so if we add 2x to both sides, we have y plus 2x equals 3, and then from there we can see that we've now got a positive coefficient of x, so we can just solve it like we normally would. So minus y, so 2x equals 3 minus y, and then divide by 2 to get x equals 3 minus y over 2. So we can see that the way to get around it here is, if you add the x part to both sides, that ends up switching the sign, so it goes from a negative to a positive. So that is one way of doing it. There is another way though. What we can do is, so if we had y equals 3 minus 2x. What we would normally have done is tried to get it so x was on its own. So we would do that by subtracting 3. So we'd have y minus 3 equals minus 2x. So what else could we do to this? So we've got minus 2 times x. The other thing we could do is divide by minus 2. So that would be y minus 3 over minus 2 equals x. So we can see actually what we've got here, we've got a different answer to what we had over this side. So in both of them we've got x equals, and then we've got a 3 and a y on the top, but the signs are the other way around. And on the bottom of this one we've got a minus 2, whereas on this side we had a 2. Well, actually these are the same. So with equivalent fractions, if you times the top and the bottom by something, it'll be equivalent. So with this, all we're doing is on the fraction, we're switching the signs of all of it. So we're timesing the top and the bottom by minus 1. So we are keeping it equivalent, we're just timesing it by negative. So we end up with minus y plus 3, and then we're switching the sign of the 2 as well to be 2 rather than minus 2, and that equals x. We don't do anything to the x side because we haven't actually changed it, we've just kept it equivalent. So here we've got as well, so 3 minus y is the same as minus y plus 3, so we can see that we do end up with the same answer. I would just say use whichever method you prefer. I think, to be honest, this one is probably a little bit easier to wrap your head around, but I think when you get confident with it, this one is maybe slightly quicker. So I'd maybe start with this one and then move on to this one if you fancy a bit more of a challenge. So let's do a couple of practice ones where we've got a negative version of x and we're trying to make it the subject. If you are feeling happy with this, you can just go straight on to the task of Dr. Frost one. So if you want to pause the video now and have a go, and I'll just run through them. Okay, so with this one we've got a minus x equals b, so I'm going to use method 1 for this. So a minus x equals b. So we're going to add x to both sides to get rid of the negative sign. So we end up with a, and then we had minus x, but we've added x, that now vanishes. We've got b plus x on this side. And to get x on its own, we need to subtract the b. So we've got a minus b equals x. So that one is sorted. We've got x on its own. And I'll shift it over to the left-hand side just because that's the more common form. Okay, and this one, okay, so you can see not only have we got a negative one, it is also an algebraic one. But you'll see that the method is really similar. So 1 minus bx equals c. So first thing we're going to do, try and get rid of the negative term, so we're going to add bx to both sides. So 1 equals c plus bx. We need to get this chunk on its own, so we're going to subtract c from both sides. So 1 minus c equals bx. And then last thing to do, we've got b times x, we need to divide by b. So again, just because it's algebraic, we can still just treat it like a number. So 1 minus c over b equals x. And note here I've divided the whole side by b. So to put that in the more common form with the x on the left, we've got x equals 1 minus c over b. So we've got that, we've got x as the subject, so it's on its own on one side of the formula. Okay, so if you want to do a little bit of practice before going on to Dr. Frost of these sort, where you've got a negative x coefficient, there's a few here. I'll put the answers up in a second, but I won't run through these ones. So the first one, we've got x equals b squared minus c, and here are the other ones. So they do get a bit harder. I think this last one is probably a little bit above what you need at this point, but if you can do it, that's great, really well done. Okay, so the task today is on Dr. Frost. I have put on Firefly an extra sheet with some really hard ones, so don't worry too much if you can't do the ones on the extra sheet, because they are definitely a step up. Particularly the last few, they're probably above even year 11, so higher than GCSE level questions. So if you can do them, you've really mastered this topic, but if you can't, really don't worry, you've got several years to get to that point yet. So good luck with the task, and email me if you have any questions.